Hello everyone, welcome back to the computer network series. Have you ever been on a call where the audio suddenly turns total static, or tried streaming a video that keeps buffering because your Wi-Fi signal is too weak? In data communication, getting your message from source to destination cleanly comes down to two important metrics. Number one is signal to noise ratio. Number two is bit error rate. Today we will be breaking down to understand what these mean, how to calculate them, and how engineers use them to keep our modern networks run smoothly. Before looking at the actual ratio of signal and noise, let's define two parts. A signal is an electrical, optical, or electromagnetic wave used to carry information from the sender to the receiver. Fine. A signal can be like your voice on a phone call, Wi-Fi data, or TV streams. Noise, on the other hand, is any unwanted disturbance that corrupts that original signal. Think interference from lightning, electrical motors, or thermal noise in circuits. This brings us to signal to noise ratio. Signal to noise ratio is the ratio of the signal power to the noise power. This SNR indicates the quality of the communication channel. Because raw SNR values can get massive, engineers usually convert them into decibels using the logarithmic scaling. Let's do a quick calculation now. If a signal power is 100 watts and noise power is 10 watts, SNR will be equal to 100 divided by 10, that is 10. In decibel, that becomes 10 dB. What if signal power jumps to 500 watts while noise power drops to 5? SNR becomes 100. In dB, it is 20. So, what do these numbers actually mean for performance? Why is signal to noise ratio so helpful in networking? Yes. A high SNR means maximum throughput. A low SNR means dropped packets. SNR helps you to maximize user experience and network efficiency. It will also guide optimization and network design. SNR gives us a very excellent quality. Medium is acceptable, while low SNR results in poor connection. If SNR gets too low, the communication completely fails because the receiver can no longer distinguish the message from that of the background noise. Several real-world factors degrade SNR. It could be the distance between the sender and the receiver, or any electromagnetic interference, maybe weather conditions, obstacles like walls and buildings, or even the quality of the transmission medium. Okay, to boost this SNR, what should I do? Engineers can increase the transmission power, switch to fiber optics, can add shielding or apply error control techniques. Even placing your home Wi-Fi router out in an open area boosts your SNR. This applies to almost all communication medium from 4G, 5G, satellites, optical fibers, radio communications to television broadcasting. When noise interferes with a signal, bits get flipped. I mean to say, a transmitted 0 might be received as 1 or vice versa. A bit error occurs when a transmitted bit is received incorrectly. Bit error rate is a ratio of the number of erroneous bits received to the total number of bits transmitted. So this is going to indicate the quality of the communication channel. BER is nothing but number of error bits divided by the total number of bits transmitted. Let's look at two simple examples. If 100 bits are corrupted out of 100,000 transmitted bits, the BER becomes 100 divided by 100,000, which is 0.001 or 1 into 10 to the power minus 3. If only 20 bits are corrupted out of 20 lakh transmitted bits, the BER drops to 1 into 10 to the power minus 5. What does this mean? Remember, a smaller BER is always better. A BER of 10 to the power minus 2 is very poor, whereas a BER of 10 to the power minus 9 represents a very excellent, near flawless system. So this bit error rate is a very vital metric. It will maximize network reliability and the efficiency. It guides modulation encoding choice, assess hardware quality and shielding, validates system stability over time, and defines the SLAs. What could be the common causes for bit errors? Common causes for bit errors include thermal noise, crosstalk interference from nearby devices, signal attenuation over long distances, and even physical distortions. SNR measures how strong and clean your signal is compared to unwanted noise, whereas BER measures the actual mistake that happens as a result. A high SNR leads directly to a lower BER, ensuring fast, reliable data transfer across everything from 5G towers even to undersea optical cables. Any doubts? Post it in the comment section. Thank you. Happy learning.